Let me show you how you can connect an LCD display to any ESP32. And so in this video I'll show you how to draw the pixels on the display, and then in another video I'll show you how to move further to creating user interfaces. And so I'm using the ILI9341, as you can see over here. I'm using the SPI2, and that's the only peripheral that I'm using in this project. And so search for your LCD display, which is related to the low level functionality, which takes care of all of the initialization of the display and so forth. So I'm using the ILI9341 display. So I'm searching for the ILI9341, then paste this, okay, and then go to the first link, and all you have to do now is just to copy this command and paste it inside your project IDF terminal, so that it will be copied from the internet and pasted inside your project like this. I've already done that. Now let me show you the connection. This is basically the connection, the MISO CS clock, CS, and the DC pin, which is used to tell the display whether the new data is a command or a data actually. And so let me show you how basically this works. Also, you have to include the ESP LCD component, which takes care of the packet structure used to initialize the display. And so if you go to the CMake lists file, this is what you need to do here. You have to write requires ESP LCD. This component includes like the initialization functions for a lot of displays, but as I said, you will need to download your LCD display library from GitHub or that registry. And so now after we've done that, let me show you the code. Here we initialize the SPI device. So we're using basically these pins. Then we initialize the SPI configuration, which takes care of the frequency and the CS and the DC line, and then the command and parameter bits. And here the panel device, the configuration basically implies what color format we are using. In this case, I'm using the RGB 565, so it means that I'm using 5 bits for the blue color, 6 for the green, and 5 bits for the red color as well. Now we have to create a new LCD panel, the ILI9341, then we reset it, and then we initialize it. Then we have to mirror it. Also, this is not mandatory, so you can actually not include it. And then the function this on off basically turns on the display. And so you have only one essential function within this library, which draws a pixel onto the display. So it is called ESP-LCD draw bitmap. And so let me actually draw something random on the display. And so I will write for loops for int I equals 0, I less than 240, and then here I should be I++, so that I go over the whole display because it is 240 by 320 pixels. And then I will do basically another loop. Actually, this is the wrong function that I'm using. And then I'll basically write here ESP LCD panel draw, like draw bitmap. Where? What did I draw bitmap? And then here it will take the panel handle like this, and then the I, the start X position, then the start Y position, and then the end positions. So it will be I, J, I+1, and then J+1. And now you have to pass the color format, like the color structure. And so this is just a 16-bit variable, and I'll declare it. It is declared in LVGL like LV color 16 type. So I'll say like this, wait, 16 type, color 16 like this, and then I will give some random colors to it. So I'd say color 16 dot blue equals 0, and then color 16 dot green. If you're wondering what exactly I'm doing here, basically this is like the intensity of the color, and so I'm using the 0 intensity for the blue color, and here I will pass the full intensity for the green color, and then the lowest intensity for the red color. And also there's a problem with this library because the colors are arranged the other way around, and so we would have like RGB would actually mean GRB, which is something wrong related to the library, and I cannot change that. I can't change that basically. And then I say here red 0. And now after I've done that, let me actually change the color format, and so actually I pulled the address of the structure like this, and then I'll set the color structure to something else. For instance, I don't know, it will be the value of the I, so I'll say I, and then size of color 16 like this, and I think that's it. So basically this will draw a random pattern on the display. And so let me actually run this. And by the way, if you're interested in learning more about embedded systems, if you want to get more access to me, I've started actually a free 5-day challenge in which I teach beginners how to develop AI and IoT applications from scratch on these microcontrollers. And so since I cannot help everyone, I'm only willing to take 3 people inside my program, and you can apply to this by joining my community, link in the description. Everything is free, I'm not trying to sell you something. And now, let me record the display so you can see exactly what I'm doing. So it is actually flashing. Let's wait a little, and as you can see, it is drawing a random pattern on the display. Let's wait a little because I'm actually drawing on the whole display, so it takes quite a while for it to finish up. So that's actually how all the LCD displays work. You basically paste a pixel on the display, and then you take care of the widgets and stuff like that with an upper layer library like LVGL. And so in the next video, I'll show you how to create a user interface with LVGL. I'll see you later.